Hello everyone, this is Mackenzie Sue and Sierra Scazillo from the University of Florida here to discuss salamander capture methods. Often referred to as slimy lizards, salamanders are actually not lizard-like at all, as they are amphibians with a fascinating and unique life cycle. Among the most fascinating is the family Plethodontidae, the lungless salamanders. They rely on cutaneous respiration, meaning they breathe through their skin. In this presentation, we will focus on the genus Desmognathus, who are predominantly aquatic, dwelling in or around small freshwater streams and creeks. Hand capturing salamanders is a common and straightforward way of capturing individuals. However, this method poses some serious flaws relating to efficiency, health of the salamanders, and the preservation of the microhabitat. Here, we will review various capture techniques used for the genus Desmognathus and recommend a preferred method. In order to determine the best capture technique, we used risk of injury or disease, bycatch, selectivity, and microhabitat disturbance in our evaluation. Hand capture for amphibians is common, but methods can vary. Examples include nocturnal or stream searches where the observer will conduct a visual search and collect any individuals present. For salamanders and other amphibians, it is common to flip over rocks and check under leaf litter to find individuals as they prefer cool, moist environments. This method is beneficial because it is relatively easy to capture salamanders by hand and does not require trap setup or material costs. Time of capture can be arranged when salamanders are most active, therefore this method often yields higher results than a passive technique. There is no time spent waiting for a salamander to enter a trap or risk of predation, desiccation, or drowning as seen in other methods. On the other hand, cutaneous respiration leaves salamanders especially prone to diseases like chytrid, which is easily passed on bare hands and gloves. Proper sanitation precautions would require new gloves for each salamander. Desmognathus juveniles have slippery skin, which makes it easy for them to slip out of your hand. Individuals can easily escape into small cracks and crevices in rocks that your hand cannot reach. Hand capture often requires sifting through rocks, sediment, and leaf litter to find the salamanders, which damages delicate microrefugia. Hand capture is also heavily reliant on the observer's ability to find them, which can create bias for larger individuals that may be easier to spot compared to smaller species or juveniles. Funnel traps are typically made of wire or mesh and are designed so that animals can enter but are unable to exit the trap. Traps have a tapered end or ends that guide individuals into the trap. Once inside, they are unable to get back out of the small entrance. Funnel traps are passive, so they are time efficient and allow for continuous sampling throughout the day compared to an active method. In aquatic habitats, these traps do not disturb vegetation, substrate, or turbidity. They are very cost efficient when the right materials are used. On the other hand, funnel traps are likely to have bycatch of species in similar size as the trap entrance. Leaf litter bags are a trap in which rocks are placed in the bottom of a mesh bag and a layer of mosses or leaves are placed on top. The bag is pulled tight, leaving just enough space for a salamander to enter, then submerged in the shallow waters of a stream bed. The leaf litter will attract salamanders, and the bag can be emptied and put back into the stream as frequently as desired. Benefits of this method include no direct contact necessary for capture, no major disruption to the stream bed, and the ability to capture multiple individuals simultaneously. Salamanders can also enter and leave at will, which reduces mortality. Leaf litter bags might also result in bycatch, such as crayfish and tadpoles. Dip netting is a method in which a net is used to collect aquatic species. Net mesh size varies and is chosen based on the target species. These nets are used in shallow areas with emergent vegetation or should be dragged along the streambed to have the best chance of collecting larvae or species that use the substrate as cover. There is a lower time investment per catch compared to funnel trapping, and dip nets allow for more particular selection of species-specific sampling if desired. On the other hand, dragging the net across the streambed damages any existing foliage, disturbs sediment, and disrupts the microhabitat. Survey comparisons can be challenging as well, based on differences in surveyor technique and effort per catch. Based on our selected criteria, we determined that the best capture method for Desmognathus salamanders would be leaf litter bags. They are cost efficient and have low risk of injury and disease. There is also a lower chance of bycatch since individuals have a way out. These traps can be highly selective for this genus and exhibit low microhabitat disturbance. We would like to take the time to thank all of our sources and our viewers. If you have any questions or comments, we would love to hear your feedback below, and thank you again for watching.